everybody, it is Malik, and we're gonna do something a little bit different today. Instead of hitting the site and figuring out how to break into something, it's time to cover some stuff that you'll hear about in A Plus or Net Plus and even Security Plus. First off, what is DNS and how does DNS work? Okay. So this is just a big overview of what DNS is. Of course, it goes much deeper than this, but this is a great start for what DNS is. Now, what is DNS? Well, DNS, of course, is short for Domain Name System. Very, very simply put, it is nothing but the phone book for the Internet. It matches what we call the fully qualified domain name to its corresponding IP. So when you open up a browser and you go to google.com, well, that's the canonical name. The Internet has no idea where google.com is. It needs to know the IP address of google.com, and that's the only way it can get you to the page. That's what DNS does. So it came about in the early 1980s as the Internet was getting far larger. Before then, we could get to sites by their IP. But the Internet was growing at such an alarming rate, it was impossible to remember so many IP addresses. On average, we have approximately 130 root servers, so I'm going to show you in a minute. These root servers hold the information for what we call the top-level domains, the .coms, the .nets, the .govs, the .uk, the .cas, et cetera, et cetera, et cetera. For every top-level domain, there is a root server for it, or a set of root servers for it. It's not just one. There is a misnomer out there that there's only 13 root servers, and that's totally false. That's way more than 13, and it's not 13 and they're duplicated or replicated. There are over 130 root servers. So if we got rid of DNS, we would actually have to visit websites by their IP address, and that could be an issue. This is the last snapshot. I think this was done end of 2017 for most of the web servers. It's not every one of them, but it's the majority of the web servers. You can see there's a lot in the States, there's a lot in the Middle East. You know, they're kind of scattered all over the place. Yeah, there's even one up in Ireland. A couple in New Zealand, but these are the root servers, and again, they control the .coms, the .nets, the .edus, all of what we call the top-level domains. Now, of course, I just took a snapshot here. I just typed in google.com, hit enter, and it took me to the Google page. Well, DNS did that. I typed in Google, and a whole lot of stuff happened on the back end, and it brought me to Google page. Now, there's another way to go to it. If you know Google's IP address, and they do have multiple, but one of them is 172.217.12.196, you can type that directly in your browser and hit enter. That will take you to Google also. Now, I didn't hit enter on this snapshot because if I would have, that IP address would have changed to www.google.com. It doesn't hold the IP address up in the address bar. It turns into its canonical name. So you want to get to websites and show off? Give out their IP address. It's also a great way to test DNS. If you think there's an issue with DNS, try to go to a website by its IP address. If you can get to it by its IP but not by its name, there's something wrong with DNS. So, how does it work? So that's your client machine on the left. That's the website you want to go to. So thisismysite.com. It's got an IP of 69.17.65.40. So you want to go to this. So you type thisismysite.com into your browser. Well, the first thing that happens is your machine asks itself, do you know where the site is at? Do you know the IP address? Now, it is possible your machine knows it. There is a local cache on your machine that stores visited pages. And even though it's not used too much anymore, there is a host file on your machine that you can put in IP addresses and websites, and they will be resolved locally. Now, let's say your machine doesn't know it. Well, if it doesn't know it, it typically asks your ISP DNS servers. And you're going to say, hey, do you know the IP address of thisismysite.com? Now, I do say typically because you can change this. In your router at home, you can put in your own DNS servers. You could jump to Google's DNS servers, 8.8.8.8 or 8.8.4.4. I use OpenDNS, not only because I love their DNS servers and they're stupidly quick, but I can also do content filtering with them. But let's say you ask your ISP. Well, your ISP is going to look through its records on its DNS server. Now, if it doesn't know, it's going to ask the root server associated with the top level domain. So you're going to .com. So it's going to ask a .com server. It says, hey, do you know where thisismysite.com is? Basically, what is the IP address? The root servers is going to ask the authoritative server, the ones that hold the ranges for the .coms and the IP ranges for the .coms, what is the IP? So it's going to ask the authoritative server, what is the IP of thisismysite.com? Well, this is the authoritative server. It knows the answer. Since it knows the answer, it's going to send you the answer, the IP address, and now you're going to be able to get to the site. Now, just so you know, all of this stuff happens quicker than you can blink, typically. It could be slower, yes, depending on traffic. Typically, though, it happens faster than you can blink. Now, DNS is not without its own issues. DNS servers can be attacked. There have been DNS poisoning and DNS spoofing. They can send you to the wrong website. So, if I know you're going to google.com, of course that web server has google.com and a record and has the IP address associated with it. Well, what if I can get to that DNS server and change that IP address to a web server that I own? The page looks like Google, but it's really not. Okay, you're not going to Google, you're going to a fake page. That's what we call a record manipulation. There are DNS amplification attacks where typically botnets can go out and do a ton of queries to DNS servers with a spoofed IP of yours, in which case you're going to get the answers, which is going to flood your system and typically crash it. And of course, the famous DDoS attacks, a distributed denial of service attack. This is done to take the DNS servers down. It's a sheer volumetric attack to send it so much data, it actually takes down the DNS servers. Of course, if the DNS servers go down, you cannot be routed to the pages that those DNS servers know about. So it could lead to a total internet outage. And to show you, it actually did. Now, there are protections we can put against it. There's DNSSEC that will stop poisoning and spoofing, and Cloudflare to stop DDoS attacks and amplification attacks. But let's take a look at this baby. One of the biggest DNS attacks ever. In October 21st of 2016, the DNS services at DN were attacked with a massive DDoS hit. The map that you're seeing here, the red areas are total internet outage. The orange areas are partial internet outage. I don't remember how long they were down. I believe they were down, I meant to look it up because I don't want to give you a wrong figure. It wasn't like all day. It was just a while, but it was still completely down. There was no internet surfing at all. All DNS servers that routed traffic, even if they routed to another DNS server, could not route because they were non-functional. Okay. So as I said, that's a big overview of DNS. But keep something in mind here. DNS servers hold more than just one type of record. There is a record that we call the A record. That maps an IP address to a host name. Now, there's the AAAA record, the 4A record, that maps host name to IP addresses, which is really the reverse. There is what we call a CNAME record that is an alias of one name to another. It's more like a redirect. There is an MX record that maps a domain name to a message transfer agent. This is for your emails. MX is mail exchange. And there's even something called a TSIG record. That's a transaction signature. This is for authentication when there's going to be a dynamic update to a DNS client or DNS server. So it verifies that that change of the record is authenticated before the DNS server actually takes it. Very, very similar to DNSSEC, which is what DNSSEC does. It doesn't allow for zone transfers that are unsigned. They must be trusted zone transfers. Before my DNS server accepts a record from yours, it must make sure that that record is authenticated. Keeps people from poisoning DNS records. So, there are many more records, but they're your big ones, and that is how DNS works. So that's the main concept behind DNS. That is enough information you need to know to pass the DNS part of A+ and even Net+. All right, so this is Malik, and I'm out, and I'll be back again shortly with maybe some more tutorials on some pretty cool stuff. I've already done some stuff on subnetting, so I'll leave that alone. But maybe we'll get into IPv4 versus IPv6, and definitely into firewalls and firewall rules. Until later, my friends, have a great day. Hit that subscribe button, click that notification bell, and definitely let me know if there's anything that you want to see. I will be more than happy to post it. Until later, my friends, this is Malik.